Today we are doing Math 6, Mission 4, Lesson 1. Size of divisors and size of quotient. So we are going to talk about what divisor and what quotient means today. All right, find the value of each expression mentally. So it wants us to do this in our head. Okay, so I have 5,000 divided by 5. So I can look at that as 5 divided by 5. So I am putting 1 in each group, right? But it's really, I have to add up to 5,000, so it would really be 1,000 in each group. Because I'm dividing by 5, it's like I have 5 groups, and then within each group I have 1,000 in there. So what is one of those groups? That would be 1,000. So 5,000 divided by 5 equals 1,000. Okay, now I'm doing 5,000 divided by 2,500. In that case, I can do 5,000 divided by 2,500. And we can divide both sides by 100, which gets rid of 2 zeros. So it's really like we're doing 50 divided by 25. Well, I know 25 goes into 50 2 times. So 5,000 divided by 2,500 is 2. Okay. Then we're going to do 5,000 divided by 10,000. Well, 5,000 divided by 10,000, like this, I again can divide this time by 1,000 and take off 3 zeros from each one. So that really leaves me 5 over 10. And I know 5 divided by 10 gets me 0.5 because that's 5/10. And in a decimal form, that's 5/10. So 5,000 divided by 10,000 is 0.5, 5/10, or 1/2. We can also write this as 1/2. If you notice, when my first number is smaller than my second number, we are going to get a decimal form. So here we go. 5,000 divided by 500,000. Again, we're going to get a decimal form. It's going to be smaller than 1 on this. So we're going to do 5,000 divided by 500,000. Now I can divide by 1,000 for each one, so it takes off 3 of those zeros. So that's like 5 divided by 500. Okay, so I can then reduce that 5 divided by 500 because 5 goes into both of those, and that leaves me 1 over 100. And I know how to change that into a decimal, so that would be 0.01 because I need that 1 in the hundredths place value. Okay, so what they're trying to get us to see is that when we have a larger number divided by a smaller number, we get a pretty big number. Oh, it got away from me. That's okay, you can go back and look at that. But this is 1,000, this is 2, and I don't know why it's jumping on me. 2, this one is 0.5 or 1/2, and this is 0.01 or 1/100th. So as you can see, when we are dividing a larger number by a smaller number, our answer is pretty large. When we are dividing a larger number by a slightly smaller number but still quite large, we get something close to 2 or 1. If we are doing something that is a smaller number divided by a larger number, we are going to get a decimal. And if it's really big, we're going to get a really small decimal. All right, let's move on. Activity 1. Here are several types of objects. For each type of object, estimate how many are in a stack that is 5 feet high. Be prepared to explain your reasoning. All right, so we are trying to decide how big each one of these things are, how tall they are, right? So I don't know exactly how tall a cardboard box is, but we're going to estimate for ease that it's 1 foot. So if we have 5 feet that we have to fill, right? 5 feet that we have to fill, that means we need 5 1-foot boxes. So how many cardboard boxes can fit into 5 feet? Well, 5 can, if they're 1 foot tall. And we're going to assume they're 1 foot tall. Let's look at notebooks. So the notebooks are pretty small. I would say they're probably smaller than an inch. So let's say that they're 1/2 of an inch. Well, we need to know how many inches are in 1 foot. So if each notebook is worth 1/2 of an inch, then that would be 2 books in 1 inch. And then how many inches are in a foot? Well, there's 12 inches in 1 foot. So that means we're going to have to multiply 2 books, because that's 1 inch, by 12 inches. So that gets us 24 books in 1 foot, but we have 5 feet. So we're going to then have to multiply that by 5. 4 times 5 is 20. That's 12. So how many notebooks fit in 5 feet? That would be 120 notebooks. Let's do bricks. I'm going to say bricks are 2 inches. Okay, so if we have each brick worth 2 inches, how many inches is in a foot? Well, there's 12 inches in a foot. So we're going to need to multiply the 2 inches by 6 to get us 12. So that means there are 6 bricks, because if each brick is 2 inches, we need 6 bricks to equal 12 inches. So we have 6 bricks in 1 foot. So then we have to multiply that by 5 because we need 5 feet, and that gets us 30 bricks. We have 30 bricks in 5 feet. Okay, coins. Now coins are really thin. So I'm going to say that 1 coin is 1/16 of an inch. Ooh, all right. So 1 inch is 16 1/16 because our denominator is 16. So we need 16 coins to equal 1 inch. Okay. Now, how many inches are in a foot? Well, there are 12 inches in the foot, so we need to multiply 16 by 12 to see how many coins are in 1 foot. So that is 12, 3, that's 6, that's 1. So we have 192 coins in 1 foot. Now we need it in 5 feet, so we're going to multiply 192 times 5, and that gets us 960 coins. 960 coins in 5 feet. All right, let's move on. A stack of books is 72 inches tall. Each book is 2 inches thick. So we have 72 inches tall. Each book is 2 inches thick. Now, if you noticed up here, we did a lot of multiplying to see how many books are in 5 feet, how many cardboard boxes are in 5 feet, how many bricks are in 5 feet, how many coins are in 5 feet. We multiplied, but here they are telling us the stack of books is 72 inches tall, and each book is 2 inches. So now we have to decide which expression tells us how many books are in the stack. So if we have a total of 72 inches, and we know each book in there is 2 inches, right? We need to see how many 2 inches there are in that stack, that 72-inch stack, right? Because that will tell us how many books go in each, or how many books there are in that whole stack. So basically, we need to do 2 inches times something to get us 72. Well, is that a possibility up here? I see 72 times 2. That doesn't work. 72 minus 2, why would we just minus 2? We would have to minus 2 over and over and over and over and over again. So that doesn't work. 2 divided by 72, are we taking 2 inches and cutting it into 72 little pieces? No, so that doesn't work. Are we taking 72 and cutting it into 2-inch pieces? Yes. So that's this one. Because if you look, if we rearrange this, we can have, to find this one, we could do 72 divided by 2, and that will get us what we're missing. Okay, let's look at this next one. Another stack of books is 43 inches tall. Each book is a ½ inch thick. Write an expression that represents the number of books in the stack. Well, we just found the expression when we had 72 inches tall and 2 inches thick. The expression doesn't change just because the numbers do. We are taking 43 inches tall stack and dividing it into 1/2 inch books. So that would look like this: 43 divided by 1/2. And because it says it's an expression, that means we do not, no equals sign. We don't actually solve it. It's just wanting us to write the expression. So you don't do an equals sign and you won't have an answer. Okay. So before we move on, I want to talk about 3 words. There are 3 words that I want to talk about, and I'm going to go down here to talk about them. So we have, let's use the example that we had, 72 divided by 2 equals, and then 36. So this is an equation, not an expression, because we have this end here, the actual answer. All right, so 72 is our whole. That's what we are dividing, okay? And then 36 is our answer. So when we're talking about division, the whole is called what's called the dividend. The dividend. And you have to know this vocabulary. So the whole is the dividend, okay? Then we have what we are dividing by. And this one is called the divisor. Now, a divisor is the number we divide a number by. So if we had A divided by B, B is the divisor. All right, then we have 36, and this is what we call the quotient. The quotient. And the quotient is the answer to a division problem. Okay? So the whole is the dividend, the divisor is the number we divide a number by, and then the quotient is the answer to the division problem. All right, let's jump back up here. We are going to work with some divisors, dividends, quotients. All right, so here in black, we have a list of numbers. Without computing, so we're not actually going to compute them, estimate their value and arrange each set of expressions in order from largest to smallest. Okay, you are going to record set 1, which is the black set, here in order. I am just going to number them up top. You are going to actually write them down. Okay, so when we are looking at these, remember we talked about in the first one that in our warm-up, we talked about the fact that when we have a, and we're going to use this vocab, dividend that is larger than the divisor, we're going to get a bigger number. When we have a dividend that is smaller than the divisor, we're going to get a smaller number, a decimal, right? So we need to look at this and put it in order. So I look and say, ooh, look, 800 and 801, those are really close together. So those are about 1, right? Because if you do 4 divided by 4, 4 divided by 4 is 1. So 800 divided by 801 is going to get us close to 1. Now remember, we're not supposed to actually solve these problems, so we're going to have to think through this, okay? So I have this one, which is 800 divided by 0.0001. So that's tens, hundreds, thousands, 10,000s. 1/10,000th. So if I was going to write that as a fraction, that's what this looks like. 1/10,000th. That's pretty small. So if I'm doing largest to smallest, this one is going to be number 8 because it's the smallest. Okay? That's going to get me, I'm sorry, that's going to, the 1/10,000th is going to be the smallest divisor, so that's going to get me the largest number. So this is going to be number 1, okay? Then we need something smaller, just a little bit bigger than 1/10,000th. So if we're going to look, we have 10,000, we have 801, we have 1,250, we have 1/10th, we have 250, we have 2 5/10ths, and then we have 799.5. So 1/10th is a decimal. It's smaller than 1. So this is going to be number 2. Then we're looking, the next smallest divisor is 2.5, so that's 3. The next one after that is, ooh, we're going to have a big jump. 250 is going to be 4. Then we have some close to 800. So we have 801 and we have 799.5. So 799.5 is going to be 5. 801 is going to be 6. Then we have 1,250, which is going to be 7. And then finally, we have 800 divided by 10,000, which is going to be our smallest quotient. Okay, so you need to write these down here in order from largest quotient to smallest quotient. And remember, a quotient is an answer to a division problem. All right, let's look at set 2. Set 2 is in the blue. Now, if you notice, all of, there we go. All of our divisors are 25. So our wholes are changing, so our dividends are changing, but our divisors are staying the same. Okay, so now we have to look at this as, again, it wants largest to smallest. So our dividend, our whole, has to be really big in order for us to get a bigger quotient. So we're looking for our dividends to be big to small. So my biggest one that I see there, my biggest dividend that I see or whole is 5 million. So this is going to be number 1. That's going to get us our biggest answer, our biggest quotient. All right, now let's look. Which one is next after this one? Ooh, 1,000 is our next biggest. So this is 2. Then after that, it looks like it's 625. That's 3. Then 75. That's 4. Then we have 6 2500ths. We have 625 10,000ths. So that's pretty small. We have 24, and we have 25 and 2500ths. So the next largest would be 25 and 2500ths, then 24, then 6 and 2500ths. Then our smallest is 625 10,000ths. Okay, so you need to write that in order under set 2. All right, and then finally it says, without computing, estimate each quotient, remember that's the answer to a division problem, and arrange them in 3 groups: close to 0, close to 1 and much larger than 1. All right, so close to 1 is going to be pretty easy because remember, if we do 4 divided by 4, that's going to get us 1. So close to 1 means anything that's within 1 or 2 of each other, depending on how big or small the number is, right? Because if it's like 10,000, we could do 950 divided by 10,000, and that's going to get us close to 1. But if it's 5 and 1, that's not going to get us close to 1. So let's look. We're looking for things that are almost the same. So like 9 divided by 10, that's going to be close to 1. Do you see that? Because we are 9 and 10 is only like 1 apart. So 30 divided by 1/2, not going to work. That's definitely not close to 1. 18 divided by 9, that's not close to 1. 15,000 to 1,500,000, no. Oh, you can see here, 15,000 and 14,500. That's pretty close to 1. All right. Let's look. I don't think I see any others that are close to 1. So let's look close to 0. So close to 0 is going to have a small whole, a small dividend with a really big divisor. So small dividend, really big divisor. We have 9 divided by 10,000. That's going to be a decimal. It's going to be close to 1. We have small dividend divided by massive divisor. 15,000 divided by 1,500,000. Big difference. Okay. All right. So then we're going to do much larger than 1. Okay. So this is going to be a really large whole or dividend with a small divisor. So you can see 30 is quite large and 1/2 is quite small. So that's going to be larger than 1. Again, 30 divided by 45/100, that's 45/100 is close to 0.5, which is 1/2. So that's going to be much larger than 1. 18 divided by 9, that's 2. That's much larger than 1. And 18 divided by 18/100, again, much larger than 1. So you have to be able to reason this out. It's very important that you understand how to do this. All right, please go through your lesson summary.